In this video, we're going to talk about the mean and variance of a linear combination of a discrete random variable. For that, we're going to define a new variable y. We're going to define it as a linear combination of x like this. So y is going to be a times the random variable x plus b. Now, what we're interested in learning about this random variable is how do we calculate its mean and how do we calculate its variance. So we're going to start with the mean. To start with the mean, we need to begin with the definition of the mean. So we know that the mean or the expected value for y is going to be the same as the expected value of ax plus b. And we know that the expected value of these sort of variables is calculated through the sum from I equals to 1 until n of each of the outcomes, axi plus b, times the corresponding probabilities bi. So what we have is the sum from I equals to 1 until n of axi pi plus b pi. Now if we distribute the sum, we can bring outside all of the constants. For example, we can write a outside, and then inside in the sum, we only get xi pi. And in the second term, we would get the sum, and b goes outside, pi stays inside. The sum of all the probabilities from I equals to 1 until n is adding the probabilities of all of the outcomes, and we know that that sum has to equal to 1. So this term is going to be reduced to simply b. Now, this sum in the first term is xipi. This is a weighted average. So this is going to correspond to the expected value of x. So what we get from here is that the expected value of y is a expected value of x plus b. So what this means is if we want to find the expected value of a linear function of x, then we can just find the linear function evaluated in the expected value of the original variable. Now let's see how we find the variance for a random variable of this kind. Now let's consider the variance. For the variance of the variable y, we need to consider the variance of the variable ax plus b. Now, the variance of this kind of variable can be measured as the variance of ax plus the variance of b. Now, b is a quantity that is constant, so the variance is going to be 0. It won't change. So the only quantity that we need to take care of is the variance of ax. Now, to look at the variance of ax, we can calculate it in the following way. It's going to be the expected value of a squared x squared, the expected value of the squares, minus the expected value of ax squared. Using the result that we found here for the expected value of y, we can use that result to say that the expected value of a squared x squared is going to be a squared expected value of x squared minus, and we know that we can apply that to this term as well, so we can write this as a expected value of x, everything squared. So this becomes a squared expected value of x squared minus a squared expected value of x squared. Now if we take the a squared out as common factor, we get expected value of the squares minus the expected value of x, and that is the variance of x. So the variance of ax, or the variance of y, is a squared, the variance of x. So now we get the relationship. Variance of y is a squared, the variance of x. Next, let's look at an example. Given that x is a random variable with the expected value of 5.3 and variance 1.2, find the expected value and variance of the following variables. So for the first case, we have 3x the expected value of 3x would be the expected value of x multiplied by 3. So the expected value would be 3 times 5.3, and that is equal to 15.9. Now the variance of 3x is going to be 3 squared the variance of x. So that is going to be 9 times 1.2. And that is equal to 10.8. In the case of b, the variable is x plus 3. In this case, the expected value of x plus 3 is the expected value of x plus 3. So that is 5.3 plus 3. That's 8.3. And the variance for x plus 3 is going to be the variance of x. So the variance of x plus 3 is 1.2. Then in the third case, we have the expected value of 4x plus 1. We found that the expected value would be 4 times the expected value of x plus 1. That is 4 times 5.3 plus 1. And that is 22.2. Then the variance for this variable for x plus 1 is going to be 4 squared the variance of x. So it's 4 squared times 1.2. And that is 19.2. Take a look at the remaining variables that we have in D and in E. Now it's your turn. Can you find the expected value and the variance for these two random variables?